Hello everyone. In this series we will try to understand data structures and implement them in Java. For the first episode we will see linked lists. Linked list is a series of elements that are linked together and each element follow the same structure as the other element. So if we want to put this into code, I have created a class that I called linked list implementation with an interface that I called linked list. This interface only contains few functions that I will be using. Back to my class, I will start with the two elements which are protected int value and protected linked list implementation that I will call next, since it's going to host the address of the next element. The first thing that I would do is to create a constructor. So let's go ahead and do that. Public linked list implementation int value this dot value equals to val, and by default the next element would be null, so that's okay. The reason why I use the protected for these variables is that I would need them later on for testing. We will see that at the end of the video. But for now, we have our constructor, we have our variables ready. I would start by making a method that would count the size of our linked list. So I would go and make a public int method, I call it size, and this would do a recursive work. I'll make a stop condition if next equals to null, then return 1. If it's not the case, return 1 plus next one dot size. This would measure the size. If the next element is null, we would get 1. For example, here if we create a new instance and we give it like, let's say int value, the value is going to be 0. Our linked list will only contain one element, so the size would be 1 based on this condition. If we have two elements that are linked together, the second one would have a null value. So our method would go for the first one, return 1 plus the size of the next one, and since the next one has a null value of the next, it's going to return 1, and we will end up with 1 plus 1, which is 2. I would add another method just to simplify the measures or the calculations for later. It's going to give me the last element of our linked list, so I would go and create a public linked list implementation last element. I would make it recursive as well, so I'll make a stop condition if next equals to null, it's the last element, so return this. If it's not the case, return next dot last element. Alright, now let's create a function that would return to us the value at the position that we will call index. Public int value at, and I'll give it int index as the parameter. The first thing that I would check is to check the size. If the index entered by the user is greater than the size of the array, then we would return -1. I'll add this condition: if index is greater than the size, return -1. If it's not the case, I would make this function also recursive. So if the index equals to 0, we would return value. If it's not, return next dot, call the same function for the index -1. And this would return to us the value of the element at the position that the user entered. Next, we would go and make a function that would remove an element from the list. This is a bit tricky because we need to take into consideration if the element is the first one, or if it's the last one, or if it's in the middle. So let's start public linked list implementation remove int index Okay, the first thing to do is to check the index if it's less than the size or greater than the size of the array. So if index is greater than the size, we would return this, because we will not be making any change in case the user wants to delete an element that exceeds the size of our array linked list. And now we will need to check if the index is the first element. So if index equals to 0, we will return, I will remove these, return next one, because we would, if we want to remove the first element of the entire array, we would just get the second element of the list and make it as being our first element, and the entire linked list would stay intact because we only changed the address of the first one. Now, if it's in the middle or at the end, we will need to loop. But to loop, we need to prepare some variables that we need inside our loop. Let's go ahead and make int temporary index out temporary index equals to 0, and a temporary linked list equals to this. And inside our loop, we would verify as long as the index is different than the temporary index plus 1, we would change the temporary linked list to the temporary linked list with the next one, and we would increment the temporary index. After we are in the position right before the element we want to remove, we will need to check if this is the last one. So we will make a condition if temporary linked list dot next. We are on the element that we want to remove, and we need to check if the next one of that element is null. So equals to null. Null. If it's equals to null, then we just simply change the next one of the element right before, which is the element we are into. Let's go ahead and temporary linked list dot next will be null. If it's not the case, the temporary linked list that we have, the next element which it points to should be the next element of the element that we want to remove. So it's going to be linked list item dot next. Once we have that ready, we would return this. So our remove method is good to go. Now we will make a method that would insert an element at a position that the user will be entering. So let's go ahead and create public linked list element implementation, insert int index and int value, the value that we want to actually insert in our list. The first thing to do is to create linked list implementation, but before that I would check the index that the user entered. So let's go ahead and create int size equals size. Then if index is greater than the size here, return this. We would not be inserting anything, but feel free to change it if you want. You can make it insert at the beginning or insert at the end. And if the index is equals to size, here we would be inserting at the last element. And since we have created a method that gives us the last element of our linked list, we'll just call it. So last element dot next equals to new linked list implementation of the value that we want to create. Once that's done, would return this, because we only made the change at the end. We did not change the first element. Now we need to check if the index is equals to 0. In that case, we need to change totally the address of the first element. So we need to create a linked list implementation that I would call res equals to new linked list implementation with the value that the user entered. Then we would change the next of that element from the default value that would be null to the value of the first element that we previously had, which is this. And then we can return res, because we changed the first element. The first element now is res, not this. Okay, now once we checked if it's the first one, if it's the last one, or if the size is not inside, if the index, sorry, is not inside our array or our list, the insert now is at the inside, and to do that we need to loop once again. We can do that recursively or iteratively, but I would prefer to use it recursively because it's way much simpler. So I would make the change on the next one to be next.insert, and we would reduce the index by 1 and give it the same value that we want, and then we would return this. Okay, now that our insert method is ready, the last thing we want to add is the update, if we want to update the value of an element at the position that the user would enter. So let's go ahead and create public boolean update. The reason why it suggested it is because we have it in the interface. Inside the update we have int index and int value, and right inside I would check, as always, the index is greater than the size. If it's the case, return false, because we did not make any change. If it's not, we check if the index is 0, this dot value equals value, and return true. This is the stop condition. And for the recursion, next.update index -1 is the value. Everything is set up. I have a little problem here with the size. Okay, it's fine. Let's just execute the test that I have already prepared. It's building. Alright, and there's the result. All the tests has been passed. I have already prepared a test for the correct element that are inserted, because I've already inserted few elements here. Test the size. I've tested to update at the first element. I've tested to remove the first element, to insert at the first element, at the first position, sorry, test here if the last element is correct, to test to update inside in the middle of the list, to remove in the middle, to insert at the last position, to remove the element at the end. I've tested the possibility to change if the index entered is out of the size, out of bound. The same thing for remove and update, and I've tested to insert something in the middle of our array list. Since everything passed, our code is ready to go. Thanks for watching, and I'll see you in the next episode.